Hi, my name is Shahroz Ahmed, and in this video I'm going to start off with the topic of GCSE maths, and the topic is sequences. So in this topic we will discuss three types of sequences in IGCSE or GCSE maths. So number one is the arithmetic sequence. The second that we have to discuss is the geometric sequence. And the third one that we have to discuss is quadratic sequence. So these are the three types of sequences that we have to discuss in this video. So let's start with the arithmetic sequence first of all. Alright, so arithmetic sequence is the one in which we have a common difference between any two numbers. So let's suppose I'm going to write a sequence. Let's suppose it's 1, 4, 7, 10, 13, 16. So you can see there's a common difference between all of these numbers. 4 minus 1, that is 3, 7 minus 4, 3, 10 minus 7, 3, 13 minus 10, 3, 16 minus 13, 3. So a sequence in which we will see a common difference, such a sequence is called the arithmetic sequence. And in this sequence, this term will be called the first term, and we represent it with A1. This 3 is called the common difference, and we represent it with T. The number of terms are represented by variable n. So n is basically equal to the number of terms, and an is called the nth term. So it means, let's suppose if I say a of 3, it will be the third term. So a of 3 will be 1, 2, 3. This is 7. If I write a of 6, it means it's the sixth term. That will be 16. A of 5, that will be 13. So this is how we represent our nth term. Now let me write down the formula in order to find out the nth term of an arithmetic sequence. So the formula goes like this: an equals to a1 plus n minus 1 times t, where an is basically the nth term, a1 is the first term, n are the number of terms in this sequence, and t is the common difference. So for example, I have to find out the 10th term of this sequence. So my n will be equal to 10, and my first term in this sequence is 1. So my first term will be 1. The common difference will be 3, and I have to find out the 10th term. So a of 10 is the one that I have to work out. So what I'll do is I'll use this formula and find out my nth term. So I'll write it over here as an, that will be a of 10, equals to a1, that is 1, plus n minus 1, n is basically 10, so 10 minus 1 times the common difference, that is 3. So it will become 1 plus 9 times 3, that will be equal to 28. So the 10th term of this sequence will be 28. So this is the formula in order to find out the nth term of the arithmetic sequence. Now let's suppose we have to find out the sum of n terms in an arithmetic sequence. So let me just write down the formula for the sum of the n terms in the arithmetic sequence. Alright, so for the formula for the sum of n terms in the arithmetic sequence is like this: sum of n terms. The formula will be like this: Sn equals to n over 2 times 2a1 plus n minus 1 times t. So in order to find out the sum, we need the first term, we need the total number of terms, and we need the common difference. So let's suppose we have 1, 2, 3, 4, 5, 6. We have 6 terms, and we want to find out the sum of these 6 terms. So my n will become equal to 6, my first term will be equal to 1, and the common difference will be equal to 3, and the number of terms are obviously they are 6. So it will be like this: 6 over 2 times 2a1, that will become 2 times 1, plus n minus 1, so the number of terms are 6, so it will be like 6 minus 1 times t, that is 3. So I'll just work it out, and the answer that I'll get is 3 times 2 plus 5 times 3. So once I'll solve it, I'll get 3 times 17. So 17 times 3 will give us 51. So the sum of these 6 terms will be equal to 51. So let's check whether it is correct or not. So for that purpose, I'll just add all of them and put that value in the calculator, and as a result of that, I will get 51 as the answer. So the sum of these 6 terms will be equal to 51, and we can use this formula in order to find out the sum of n terms. Alright, so now let's do an exam related question for the arithmetic sequence in order to understand it better. Alright, so here we have a question. It says here are the first 5 terms of an arithmetic sequence. So we have been given an arithmetic sequence, and we have to work out the expression in terms of n for the nth term. So as I've just explained you, that we'll use the formula, that is a of n equals to a1 plus n minus 1 times d. So for these terms, let's find out the common difference. So 9 minus 3 will be equal to 9 minus 3 will give us 6. Similarly, 15 minus 9 give us 6. 21 minus 15 will give us 6 as well. 27 minus 21 will give us 16 as well. Sorry, 6 as well. So the common difference is 6, and the number of terms in this sequence are 1, 2, 3, 4, 5. So our common difference will be equal to 6. Our first term, that is a1, it will be equal to 3. The number of terms are equal to 5. So what I'll do is I'll just insert these values into this formula, and we'll get the nth term. So my a of nth, it will be like 5 because there are 5 terms, so I'll write a of 5. That will be equal to, in fact, I just have to write down the expression, so I don't need to put the value of n. So what I'll do is I'll write an equals to 3 plus n minus 1 times 6. So I'll just expand the brackets and solve it. So it'll be like 3 plus 6n minus 6. So my expression for the nth term will become equal to minus 3 plus 6n, or an equals to 6n minus 3. So this will be my expression for the nth term. So this is it for question number 1, part A. Now let's move on to part. Alright, so part B says Ben says that 150 is in the sequence. Is Ben right or not? And we have to explain the answer. So what we do is I'll say that my nth term is 150, and I will use this formula, an equals to a1 plus n minus 1 times d. I have a1, I have d, I have my nth term. If I get the value of n as an integer, then this term will exist in the sequence. If n is not an integer, then it means that this term does not exist in the sequence. Why? Because a term cannot be a decimal. Either it is the first term, second term, fourth term, 11th term, 30th term, 60th term. It will not be like 3.5th term. Okay, so n must be an integer, a positive integer. So I'll put 150 in place of an. My a1 was 3, and n minus 1 times d is the common difference, that is 6. So I'll just solve it, I'll work it out. So it'll be like 3 plus 6n minus 6, so it's like 150 equals to 6n minus 3. So I'll add 3 on both sides, so I'll get 6n equals to 153. Now I'll divide both sides by 6. This will get cancelled, and from here I'll get n equals to 25.5. So as you can see that n is not an integer, so we will say that Ben is incorrect. Ben is wrong. 150 does not lie in the sequence. So this is how we can do the questions related to the arithmetic sequence. Now the next one is the geometric sequence, so let's move on to that. Alright, so geometric sequences. So in geometric sequences, instead of a common difference, we have a common ratio. For example, I'm gonna write down a sequence. It's like 2, 4, 8, 16, 32. Now you see the first term is 2, the next term is 4, so we can say 2 has been added, but the next term is 8, so 4 has been added. So what's happening here? In this sequence, each term is being multiplied by a number to get the second term. So in order to find out that number, we will divide the second term by the first term. So in this geometric sequence, in order to find out the common ratio that we represent with r, we have to divide the later term by the previous term. So it will be like 4 divided by 2, so we'll get 2. So this 2 is the common ratio, which means if we multiply this 2 with 2, we'll get 4. If we multiply 4 with 2, we'll get 8. If we multiply 8 with 2, we'll get 16. If we multiply 16 with 2, we'll get 32. And in the similar manner, this sequence will go on. Now, in order to find out the nth term for this geometric sequence, we have the formula that says an equals to a1 times r to the power of n minus 1. So nth term is equal to the first term times the common ratio to the power of n minus 1. So let's suppose we want to find out the 10th term of this sequence. So my n will be equal to 10. My first term is given, that is 2. My common ratio will be equal to 2. I've just got it, and that's what we need for this one. So the 10th term will be equal to 2 times 2 to the power of 10 minus 1. So that will be like 2 times 2 to the power of 9. So 2 to the power of 9 will be equal to 512. So it's like 2 times 512, that will be equal to 1024. So 1024 will be the 10th term of this geometric sequence. And now we will discuss the formula in order to find out the sum of a series, sum of a geometric sequence. Alright, so now we have to find out the sum of geometric sequence. So in order to find out the sum of geometric sequence, we'll use a formula that is Sn equals to a1 times 1 minus r to the power of n whole divided by 1 minus r, where a1 is the first term of the sequence, r is the common ratio, n are the number of terms, and by using this formula we can find out the sum of geometric sequence. So let's find out the sum of the first 8 terms. So for that purpose, I'll say that my n equals to 8 because I want to find out the sum of the first 8 terms, and my first term is 2, the common ratio is 2 as well. So I'll just insert these values into this formula and let's see what I get. So s of 8 will be equal to 2 times 1 minus 2 to the power of 8 whole divided by 1 minus 2. So let's work it out. So it'll be like 2 times 1 minus 2 to the power of 8. So 2 to the power of 8 will be equal to 256 divided by 1 minus 2, that is minus 1. So 1 minus 256 is equal to minus 255, and 2 times minus 255 over minus 1, so that will give me negative 510 over minus 1. So the sum of first 8 terms will be equal to 510. So this is how I'll use this formula for the sum of geometric sequence to find out the sum of first 8 terms. Now let's head down towards an exam related questions for the geometric sequence. Alright, so here we have an exam related question for the geometric sequence. It says S is a geometric sequence given that under root x minus 1, 1 and under root x plus 1 are the first 3 terms of the sequence. Find the value of x. So we have to work out the value of x and we have to show the working. Remember that in a geometric sequence we have a common ratio. Okay, so this term divided by this term will give us a common ratio. So that will be equal to this term divided by this term. So r will be equal to 1 over under root x minus 1. Okay, and r will also be equal to this term divided by this term, under root x plus 1 whole divided by 1. So because the ratio is common, so the values of r are same, so we can compare these two equations. So when we'll write them together, it will be like this: 1 over under root x minus 1 equals to under root x plus 1 over 1. I'll do the cross multiplication. As a result of that, I'll get 1 equals to under root x plus 1 times under root x minus 1. So I'll just expand the brackets and work out the value of x. So x under root x times under root x will be equal to x, then minus under root x, then plus under root x minus 1. This will get cancelled, so I'll get 1 equals to x minus 1. So I'll add 1 on both sides, so it will be like 2 equals to x, or we'll say that x is equal to 2. So x is equal to 2 will be my answer for this question. So this is how we can do a question for the geometric sequence. Now let's move on to the next part. Alright, so and then part B, it says show that the fifth term of the sequence is 7 plus 5 under root 2. So we have to find out the fifth term. So before that, let's find out the common ratio. We have found the value of x, that is 2. So I'll just insert that value of 2 over here and work out the common ratio. So I'll say r is equal to 1 over under root 2 minus 1. Or this expression does not seem to be, and easy to solve, so I'll use the other one. So the other one was r equals to under root x plus 1 over 1. So because x is 1, x is 2, so my common ratio will become equal to under root 2 plus 1. So this will be my common ratio that I'm going to use. So I'll erase the rest of the stuff, and I have to find out my fifth term. So I'll say that n is equal to 5, and I have to find out a of 5. Common ratio is given, and the first term of this sequence is this one, under root x minus 1. So a1 is equal to under root 2 minus 1, because the value of x is 2 now. I'll use the formula for the nth term. So it's like n equals to a1 times r to the power of n minus 1. So it's like a of 5 equals to under 2 minus 1, r, that is under 2 plus 1, n minus 1 is 5 minus 1, that is 4. So this is to the power of 4. Now I'll have to use I'll just have to expand it to work out this answer. So my a of 5 will become equal to, alright, let's do part B. Part B says show that the fifth term of the sequence is 7 plus 5 under root 2. So we know that the third term is under root x plus 1. If I multiply the third term, this is my third term. If I multiply the third term with the common ratio, I'll get the fourth term. And when I'll multiply the fourth term with the common ratio, I'll get the fifth term. So my common ratio was r equals to under root x plus 1 over 1, and my x was 2. So my common ratio will become equal to under root 2 plus 1. So in order to get the fourth term, I'll multiply the third term with the common ratio. And in order to get the fifth term, I'll multiply my fourth term with the common ratio. So let's find out the fourth term first, and then we'll get the fifth term. So my fourth term will be equal to a3, that is under root x plus 1, so x is 2, so I'll write under 2 plus 1. R is also under 2 plus 1, so it'll be like under 2 plus 1 whole square. And let's find out my fifth term. So my fifth term will be equal to under 2 plus 1 whole square times the common ratio, that is under 2 plus 1. So it will become under 2 plus 1 whole cube. So let's expand this bracket and show that our fifth term is 7 plus 5 under 2. So it will be like this. Here 5 is equal to, let me just expand this one, then I'll expand this. So it's like a square, So it's 2 plus 2 times AB, that is 202, plus B square times under 2 plus 1. Now I'll expand this one. So 202 plus 2 plus this terms times this term. It'll be like 2 under 2 times under 2, so it'll be like 2 times 2 plus 202. Now I'll do this one. It'll be like under 2 plus 1. So I'll just solve it. So 202, 202, and under 2. So this will become 5 under 2. 2 plus 4 plus 1, that will become 7. So my fifth term will become equal to 7 plus 5 under root 2. So this is how I'll work out part B. So this is it for the geometric sequence. Now the next one that we have to cover is the quadratic sequence. Alright, so now I'll discuss the quadratic sequence. So quadratic, in the quadratic sequences, let me just write down a sequence first of all, and then we will see how we can find out the expression for a quadratic sequence if we have been given a sequence. Alright, so here I have written a quadratic sequence that is -1, 9, 23, 41, and 63. So what's interesting in the quadratic sequence is that there is no common difference in it, there is no common ratio in it, but the second common difference is equal in the quadratic sequence. So let's see how we can find out the second common difference. So when we subtract 9 minus 1, we will get 10. When we'll subtract 23 minus 9, we will get 14. When we'll subtract 41 minus 23, we will get 18. And when we will subtract 63 minus 41, we will get 22. So these are the first differences. Now let's take the second difference. So the second difference is 14 minus 10, that is 4. 18 minus 14, that is also 4. 22 minus 18 is also 4. And before doing that, I want to let you know the standard form of a quadratic equation. So the standard form of the quadratic equation is like this: ax squared plus bx plus c. And in the quadratic sequence, we have to find out this expression. We have to find out the coefficient of x squared, the coefficient of x, and the constant. Now in order to find out the coefficient of x squared, it's quite simple. We have found the second common difference. So the second common difference is 4. So what we do is we'll get a by dividing this 4 by 2. So our a will become equal to 4 by 2, that's equal to 2. So I got a. So we got a. Now we have to work out how we can find out b. So remember, in order to find out b, it's like this: 2a plus b equals to this number. So that will be equal to 10. Alright, so I'll write it as 2a. So because this is 2, so that's why I wrote 2a over here. And a is 2. So again I'll put 2 here, plus b is equal to 10. So it'll be like, alright, so in order to find out b, it's not 2a, it's 3a. So it's like 3a plus b equals to 10. So I'll write it as 3 times a is 2. So 3 times 2 plus b is equal to 10. So it becomes 6 plus b equals to 10. I'll subtract 6 on both sides. So I'll get b equals to 4. So my b has become equal to 4. Now in order to find out c, it's quite simple. It's like a plus b plus c is equal to this number. So that will be equal to -1. So my a is 2, my b is 4, and I don't know c, so that will be equal to -1. So it's like 6 plus c equals to -1. So c is equal to -1 minus 6. So we'll write it as c equals to -7. So c equals to -7. So -7 will be our constant. So our equation will become 2x squared plus 4x minus 7. So in this equation, if we insert x equals to 1, we will get minus 1. If we insert x equals to 2, we will get 9. For x equals to 3, we'll get 23. For x equals to 4, we'll get 41. For x equals to 5, we'll get 63. So in this way, we can find out the quadratic expression from a quadratic sequence. So this is it for the topic of sequences. I hope you got the concepts. So thank you so much.